Hi and welcome everyone. So in this video we will see how to interface a soil moisture sensor with Arduino UNO. Actually, a soil moisture sensor is measuring the amount of water present in the soil. So it represents how much water is stored in the soil particles. So this is having two different parts, like one is electrode part and another one is data acquisition part. We have to physically connect these two parts with the help of two single strand wires, and the sensor unit is having four different terminals like VCC, ground, digital output and analog output. So it is very similar to MQ135 sensor. It can be able to produce digital output also. We need to set the threshold. If it is exceeding the threshold value, the sensor will give 1 as a result. If it is not reached that threshold value, the sensor digital output pin will give 0 as output, right? So digital pin is producing 0 and 1. We need to set the threshold for that, right? So if you want to continuously monitor the soil moisture, then you can prefer this analog pin. This analog pin will give some continuous value that varies from 0 to 1023. So by the way, you can able to continuously measure the soil moisture, and then you can take necessary actions. When if it is very low, you can take some decisions. When it is going beyond the threshold value, you can take some necessary actions. So this is what the pin details of the sensor, and I am connecting my analog value to the analog pin A1, and VCC and ground, these are all the power supply pins, and it can be taken out from these Arduino board itself. So now this rod has to be dipped into the soil particles, and this will produce the results according to the moisture level. Okay, so while moving on to the coding part, so this is very similar to the MQ135 sensors. We are connecting the sensor with A1 terminal, analog pin 1 terminal itself. We have connected the sensor, and the serial.begin, this is the command for starting the serial communication between the board and the laptop. And the void loop command, this is actually measuring the analog value that coming from the A1 terminal, and it is giving the data to it is stored at the variable name called my data, and it is declared as float type. And now the serial data is actually 10-bit. It is the results coming from the 10-bit ADC of Arduino UNO. So it is having maximum value as 1023 and minimum value as 1000, right? So it is printed on serial monitor or either serial plotter itself. You can able to see these results, and this is happening within 0.5 time interval, right? One basic concept of this soil moisture sensor, the dry soils are which contains less water particles, and which results in less conductivity and produces less current. Similarly, the wet soil which is having comparatively a high amount of water molecule and somehow a high conductivity we can able to observe, and high amount of current which is flowing through the electrodes. Okay, so the electrodes are the making a contact with the soil particles. So the amount of current flowing through the electrodes is getting differed for the different soil types, either it may be dry or wet, right? So that the code is now uploaded already, right? So it is showing as 1023. So I am showing the electrode now. The electrode is just free from any soil particles. I am just inserting the electrode within the wet soil, dry soil. Now it is around 900, it is showing 900, 907, 910. Likewise, it is showing around 800 or 900. The result is, it is showing the soil is dry now, right? So less amount of current, the ADC, the voltage is somehow higher than that of the, higher, it's showing the current is lower, and it is the results of soil moisture sensor. So it is dry. Now I am having wet soil also, so I am just taking out the rod and just wiping out the dry soil particles from the electrode terminals. Okay, now I am going to insert the electrodes in our wet soil. You can able to see the values of this soil moisture sensor is getting reduced. It is going beyond 700, 750. Slowly it is getting reduced. So it will reach less than 500 soon. Okay, if we want to measure the final output, we have to wait for a moment. Then the sensor data will be settled below 300. Okay, at that time itself you can able to realize that relativity, the wet soil that will give a very minimum amount of voltage from the soil moisture electrodes. So it is actually conducting more current and producing less voltage during the wet soil condition. Okay, if it is dry, it will produce less current and high volt, right? So across the terminal we are talking. Okay, so this is the actual results. It is, you can able to see in the screen, it is going beyond 400 now, right? This is the logic we need to understand while interfacing a soil moisture sensor with the Arduino UNO. So you can able to apply this concept if you want to identify the soil moisture level during the smart agriculture projects. You can able to measure the soil moisture level accordingly. You can able to irrigate the plant. If it is wet already, no need to turn on the motors. If it is dry, you can able to turn on the motor. So in order to do this automation, the soil moisture level can be easily identified with the help of this sensor. Thank you.